Good morning, students. Welcome to day 5 of our new world. I thought you might enjoy a fat man in a feed me shirt. There's a story behind it. Get to it if we get a chance. So, today, Friday, 3/20/2020. Here's our learning targets for today. I can name and define layers of the earth based on chemical composition. I can name and define layers of the earth based on physical properties. I can locate these layers on a diagram of the earth. Those are things we're working for. As I go through this, and I'm talking about physical properties, I'm going to use the words mafic and felsic some. And so we have to understand what those words are. And so those are words that define or describe types of rock or magma or lava, which of course are melted rock. So what really we have is this continuum with mafic on one end, felsic on the other end, and it's kind of centers on the mineral silica. Silica would be basically things like silicon dioxide. You've probably seen rocks made of quartz. Quartz is pure silicon dioxide. So quartz would be like as far over to the silica end as you can get, the felsic end. If you see really dark rocks, basalt is an example that we see. Basalt has not nearly as much silica in it, and it has more iron and magnesium minerals in it. That's towards the mafic end. And, you know, again, this is a whole spectrum or continuum of things. If we use the word ultramafic, meaning it's really far that way. So here's some of the characteristics. Mafic has more iron or magnesium. In fact, the word mafic, the Ma kind of comes from magnesium, and the FIC part, the old name for iron, would refer to ferric compounds, ferrous compounds, ferric. So this name really comes from iron and magnesium. What they're going to look like is mafic materials tend to be darker in color. They're more dense. Mafic rocks are more dense, and this is one of the significance that we're going to use. If you melt it, our current chapter isn't going to be quite so much on that, but later when we talk about volcanoes, if you melt the rock into magma or lava, mafic lava has a lower viscosity. Viscosity is resistance to flow. So imagine you pour a glass of water, picture what that looks like, and then imagine you pour out a jar of honey. The honey is much more viscous, it has a higher viscosity, and it doesn't flow as easy. What we're saying is mafic lava or mafic magma would flow fairly easy as far as lava goes. It has a lower viscosity. Now over on this end, on the felsic end, well, they have more silica in them. They tend to be lighter colored materials, so if you've seen a sample of quartz, it's clear, or you know, from a distance it looks kind of whitish. These rocks and magma and lava are less dense, so that affects where they're going to be on Earth. If you melt it, they're going to have higher viscosity, so that's kind of sticky magma. It doesn't like to flow very well. So mafic and felsic, those are words that I'm going to be using to describe some of the rock layers in the Earth, and so you need to have some comprehension of what they are. I know that those are kind of new words for you, new names, but any class has some vocab that you have to study. So, we're going to talk about these layers of the Earth. So let's just imagine this is our Earth, and we took a slice right through the middle, and we're going to take a look at it. And on one side of this diagram, we're going to look at this Earth based on chemical composition. Now, I got a lot of stuff that I'm trying to put on one slide here, or one page, so I'm not going to write this down, but I'm going to tell you. Chemical composition refers to what is it made of. Okay, chemical composition, one more time. What is it made of? You see that I have three basic layers here. So, starting on the outside. The outer layer of the earth is called the crust. What is it made of? Well, the crust tends to be more felsic rocks. Some mafic. Everything has a combination, but if you're going to find felsic rocks on the earth, they're going to be out in this crust on the surface. In fact, that's one of the things that kind of identifies the crust, especially continental crust. The land masses of the earth are mostly felsic in nature. Okay? So, talking about chemical composition, what are they made of? Felsic crust. The crust is felsic rock, means it's higher silica materials, not as much in the metals. Okay, the next layer is a big layer. This is called the mantle. And now I'm having one of these senior moments where I'm looking at the spelling of that, thinking, is that right? So I want to check something here. No, I didn't spell it right. My apologies. All right, so what is the mantle made of? This is ultra mafic. So ultra mafic meaning very little silica. This is heavier, dense rock. Okay, and we've got one more layer in here. This is called the core. And the core is made of metal, mostly iron. Also, we think some substantial amounts of nickel, and there's other metals in there, but a lot of iron. Okay? So, based on chemical composition, based on what it's made of, the crust of the earth is low density felsic rock. The mantle of the earth is high density ultramafic rock, and the core is made out of metal. Okay, that's fairly simple so far. So now I have the other side with different layers drawn, because we're going to use a different set of criteria. Instead of chemical composition, over here we're going to talk about physical properties. Alright, so starting from the very surface of the earth, we have a layer called the lithosphere. My guess is that you've heard crust, mantle, and core before. You may or may not be familiar with some of these. These are some different sounding words. Now, the lithosphere is characterized by being hard or brittle. Okay, so the rocks on the surface of the earth, yeah, they're hard, they're brittle. You hit them with a force, they tend to break or crack. Yeah, I guess that's enough. The next layer down, this is a weird word, it's called the asthenosphere. Asthenosphere. A-S-T-H-E-N-O sphere. S-P-H-E-R-E. So, the asthenosphere, this is really weird. It's made out of rock, but it has properties that we call plastic. So I want you to think about this. If you had a piece, if you had something, a toy or something that was made out of plastic, and you got it, one, really warm, and two, you were squeezing it, that plastic starts to deform. It starts to move. It doesn't ever get to where we would really necessarily call it melted. It's not flowing like water, but it does move around. Well, the rock in the earth kind of does the same thing. If it's hot and under pressure, it can move. It has plastic properties. And the asthenosphere is a layer of the earth that is particularly plastic. So I'm going to use the words plastic. I'll describe it as somewhat fluid. Now, it's not melted, it's not liquid. There may be pockets of melted rocks in places in here, but it's not like this is all melted rock. It's typically solid rock, but it's on the verge of melting or close to melting, and it just moves around easier when you squeeze it. All right, the next layer, I'm going to use the word mesosphere. M-E-S-O sphere. S-P-H-E-R-E. Some references use the word mesosphere. Some references just call this the lower mantle. Okay?